Lesson number 115 is on linear inequalities. Now, what we're doing here is we're graphing, but instead of graphing equations, we're graphing inequalities. So we replace our equal sign, and we'll have a greater than or less than sign, or we'll have a greater than or equal to, or a less than or equal to sign. If you wanted to, what you could do in order to graph this problem is to, instead of saying y is greater than this, we can say y is equal to negative x plus 2. If we do this step, it makes it easier to see what our y-intercept and our slope is. Our y-intercept must be 2, and our slope must be down 1 over 1. Now you can see we've got a graph that looks like this. Down 1 over 1 must be the same as up 1 backwards 1, so we can fill in some more points as we go. And we've got our line. Now, this problem is not really y is equal to negative x plus 2, it's y is greater than negative x plus 2. So what we're doing is we're looking at all y values that are going to be bigger than this line. So all y values that will be bigger than this line are up here, because these values of y are bigger than everything that falls through this line. So what we're going to do is we're going to shade everything that's above this line. And you could shade it in bold if you like, or you could just put the arrow saying we're going in this direction. Now we're almost done with our whole problem. If we have a greater than or a less than sign, that means we're going to have a dashed line. Because what we're saying, like an open circle when we're using number lines, is that this isn't really part of our solution. It's just the boundary. So I'm just putting in dashes here to show that we have a dashed line. And it'll look something like that. If, for instance, we were to have something that had a greater than or equal to, or a less than or equal to sign, well, these two would mean that we have a solid line. Now, we've got the right answer for this problem. But if this were greater than or equal to, like we have here, instead of putting the dashed line, we'd have a solid line that would go all the way through. Now I just free-handed that. Please use a ruler or a straight edge as you go, so we get a nice straight line. I free-handed it because I know that we can just undo it because it was not the right part of this problem. Just to show the difference between the greater than and less than, dashed line, greater than or equal to or less than or equal to, which will be a solid line. Let's look at another problem. Here we have y is less than or equal to 2x minus 1. So we get to practice with our solid line here. 2x minus 1. Negative 1, that must be our y-intercept. And our slope must be up 2 over 1, because 2 is the same thing as 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and we could keep doing that. We could go down 2, backwards 1, and we could keep doing that until we fill up our coordinate plane with as many points as possible so we can get a nice straight line. We really only need 2 points, but the more points the better because it will help us fill the coordinate plane. Now we'll use a nice straight edge here, and you should be using a straight edge as well as we go, and we'll connect that first point and the last point. We know this is a solid line because it's less than or equal to. Then we're going to make some arrowheads because we know we have a line and not a segment. And this one says y is less than or equal to this. So if we look at our y values on our y-axis, we want all y values that are less than or equal to this line. So all the y values that would be less than or equal to would be below it. All of these values are less than everything that happens at this point along this line. So our solution set, our inequality, will tell us that we also need to include everything on the right side of our line, because that will give us all y values that are less than it. If you wanted to, you could color this in completely. But I'm just going to use lines to represent that our solution set is here. Let's look at another one. Here we go. Y is greater than 2. Well, y is greater than 2. Here's 2 on the y-axis. Here's 2 on the y-axis. This is also 2 on the y-axis. Y is greater than 2, so we want all y values that are bigger than this. Well, this must be a dashed line, and it must be a dashed line because it's not equal to it. Okay, we're going to put the arrowheads on it as well. Y is greater than it, so if y is greater than this, we're going to be shading in everything that's bigger than this line, because all of our y values that are bigger here are above it. And I could fill in a little bit more below, a little bit more below there. We could fill in some more above if we wanted to. We could go crazy with this if we would like, but you don't have to. We've got the general idea. We've got our dashed line at y is greater than 2, and then we've got everything above it. We've got one more example. X is less than 3. If we have x is less than 3, well, 3, 1, 2, 3, that's right here. Another point where x is 3 would be up here. And then another point where x would be 3 would fall down here. Now in this one, x is less than 3. So we've got another dashed line because it's not equal to 3. So our dashed line goes down. We'll draw arrowheads on that so we know that this continues. We want all x values that are less than 3. Well, all x values that are less than 3 must be going to the left. So we can go ahead and shade that in. We'll shade that in, everything that's to the left of this line. And again, if you want to use lines like I did earlier in the lesson, you may. If you want to shade everything in, you may. Take a look at your textbook for this lesson, and you'll also see that it's bolded in everything. Your choice to show how this works. But what we're saying is x is less than 3. You want all values that are less than 3 to appear on our coordinate plane. The lesson practice will be on page 488. Make sure you've got your notes complete, and I'll see you during our next class.